For the case of a conservation of momentum using an explosion, let's make an example. So a classic one is lecturers, you'll see this occasionally, will sit on a chair, preferably on a frictionless surface, with a fire extinguisher. And they will squirt the fire extinguisher, and because the gases are going this way, they will go that way. But this only works on a frictionless surface, doesn't work on carpet. So let's say a, I don't know, 80 kg lecturer who uses fire extinguisher, fires, well, let's say 500 grams of gas, of CO2, 80 meters per second to the left. How fast do they travel? Assuming there's no friction in the system, how fast do they travel? So basically what happens here is momentum before P initial equals 0. So there's some lecturer like me just sitting on the chair, nothing's moving, so momentum is equal to 0. Then pull out the fire extinguisher and then try and take off. So let's try and see how this works. So P final is also going to equal 0 because momentum P initial equals P final. And we're going to set this up as positive, positive. So what we have to do, this means momentum left equals momentum right, or negative momentum right. So let's work it out. Momentum left, PL, it's mass L, VL equals mass R, VR. I want to find out my velocity right, so all I have to do is rearrange this equation for, so mass right, that's right, just plug in the numbers. So mass left is 0.5 kgs divided by 80 meters per second, 80 meters per second, sorry, let's try that again. 0.5 kgs times 80 meters per second divided by my mass, 80 kg, oh that's okay, that's equals 0.5 meters per second. Cancel. Okay, so this is actually negative 80. So I'm going to end up going 0.5 meters per second that way. Roaring off into the sunset. Oh. Cool. Okay, let's try another example. Again, this is example. So say you have a spaceman. Way. Put a helmet on them. So they can survive, and they get stuck somewhere. So say they're floating around on the International Space Station. An astronaut, how much do you say? M equals 75 kg, throws a 5 kg weight at 3 meters per second. So they're just going to throw a weight here. They're stuck in the middle somewhere. They're just pushing it off, so hopefully they're going to recoil and they're going to go towards a wall or something. What is their final velocity? Velocity. So it's the same thing we were just doing before. So what we have here is P final equals P initial, but because it was standing there with the weight there ready to push off, so that's going to equal 0. So this means momentum right, or P right, sorry, equals P left. So MR VR equals ML VL. We want to find out the right. So both sides by MR. Velocity is equal to mass left 5 kg. Velocity 3 meters per second over 75 kg. 0.2 meters per second. We are done.